Hey guys, welcome back to the laboratory. In this video, we are looking at the atomic number and mass number of atoms. By the end of this video, you should be able to recall what the atomic number and mass number tells us about the particles in an atom, and calculate the number of subatomic particles found within an atom using the mass number and atomic number. So, let's go. When you've looked at the periodic table, you would have noticed that each element symbol consists of two numbers. These two numbers are the atomic number and the mass number, and both are extremely useful when trying to understand the structure of an element's atoms. We'll use the element symbol for helium to explore this concept. This number here is the atomic number. The atomic number of an atom tells us the number of protons that can be found in its nucleus. The atomic number of an element is unique to that element. In other words, there are no two elements in the periodic table with the same atomic number. If you change the atomic number, you change the element. It is always best to remember the atomic number as being the smallest number on an element symbol. On some periodic tables, these numbers can be swapped around, and so it can become quite confusing if you always remember the atomic number as being the number at the bottom. This number here is the mass number. The mass number of an atom is equal to the number of protons and neutrons that are found in its nucleus. Once again, it is best to remember the mass number as being the largest number on an element symbol. We can use these two numbers to calculate the number of subatomic particles that are in the atoms of different elements. This helium atom has an atomic number of 2 and a mass number of 4. With an atomic number of 2, we know this helium atom has 2 protons. Because an atom is electrically neutral, this means it will always contain the same number of protons and electrons, and so there are 2 electrons in this helium atom. The mass number for helium tells us that the number of protons and neutrons added together is equal to 4. We already know there are 2 protons in this atom, so to calculate the number of neutrons, we must subtract the atomic number from the mass number. There are 2 neutrons in this helium atom. Here are some questions you can attempt to test your understanding of this concept. Pause the video and take your time to work through each task. Press play once you're ready to check your answers. Let's talk through the answers for this sodium atom. This sodium atom has an atomic number of 11. The atomic number tells us the number of protons, and so this sodium atom has 11 protons in its nucleus. The number of protons is always equal to the number of electrons, and so this sodium atom will also have 11 electrons. The mass number tells us the amount of protons and neutrons that will be found in this atom. And to calculate the number of neutrons, we need to subtract 11 from 23. There are 12 neutrons in this sodium atom. Here are the answers for the other questions in this task. How did you do? Let me know in the comment section below. Before we finish up, I wanted to share this past paper question with you. This is an example of how you may be examined on this particular concept. Pause the video and take your time to write a response. Resume the video once you are ready to check your answers. This question here has been pretty generous and provided you with the atomic number and the mass number already. Don't see this as a reason not to remember the difference between the two, however. You might not always be this lucky. Anyway, the question is asking you to use the information provided to calculate the number of particles in the nucleus of this atom. This automatically rules out the need to state the number of electrons, as we already know that they are found on electron shells. So, this question is asking for you to state the number of protons and neutrons found in the nucleus of this lithium atom. For 2 marks? Let's do it. If our atomic number is 3, then we must have 3 protons in the nucleus. That's it. That's already our first mark. If our mass number is 7, then we have 7 minus 3 neutrons. 7 minus 3 is equal to 4. We have 4 neutrons in this lithium atom. And that's it. Those are your 2 marks. Just as a side note, it is super important that you provide the exact information that a question is asking for. This particular question was taken from an Edexcel past paper, and a mark was deducted if the number of electrons were mentioned, seeing as they are not located in the nucleus. So, how did you do? Once again, let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!